In this tutorial, we're going to show you how to build a simple oscillator called a Oscillator. To begin with, we will drop down some molecular species, 6 species in all. By default, they're named node 0 to node 5. We are now just tidying up the layout. We can align the nodes either from the top or in this case along the left edge. First thing we will do is change the names of each node, set up an initial concentration, and decide whether they are fixed nodes or floating nodes. So we'll now proceed from node to node. Note that the two horizontal bars on the node indicates that this is a fixed node. So in this model there are only 2 floating nodes. The remaining 4 nodes are fixed and do not change during the simulation. That completes the settings for the nodes. Now we will connect the species nodes with different reactions. The first reactions are going to be 2 uni-uni reactions. The next one is going to be a bi-bi reaction that connects X and B to Y and C. We can rearrange the reaction arcs simply by moving the control points until we're satisfied. Finally, we're going to add a bi-uni reaction that connects X and Y to X. This is an autocatalytic reaction because for every X we produce additional X molecules. We are now just arranging the reaction so that this is made clearer in the diagram. That completes the reactions. We must now set up the reaction rate laws and the rate constants. By hovering the mouse over the reaction, you can see what the default rate laws and rate constants are. Some of these will have to be changed. Let us first change the reaction A to X. There are a selection of built-in rate laws one can choose. The default is OK, but we do need to change the rate constant. The same for this reaction. And also the same for the bi-bi reaction. However, the bi-uni reaction needs a rate law that isn't provided by the built-in rate laws. In this case, we need to add our own rate law using the free format page. Note also that we need to change the stoichiometry of the reaction. At the moment it's 1x gives 1x, but we really want 2x to give 3x. That completes the model. We are now ready to carry out a simulation. We bring up the time course panel, we bring up the graphing panel. We change the time end, and we do a simulation. As you can see, the 2 species X and Y oscillate. Now if we wish to study how the different rate constants affect the oscillation, we can attach each of the rate constants to sliders, as shown. To make the curve smoother, we are going to increase the number of points to 300 points. We will now dock the slider window, and then as we move the sliders, you will observe that the characteristic dynamics changes. In this way we can investigate how each parameter affects the characteristics of the oscillation. In the graph panel we can also change what we wish to plot. For example, we might wish to plot a phase plot, plotting X against Y, as shown now. That completes the tutorial.